Hey guys, and welcome back to another video on the channel. In today's video we're going to be discussing, well, pretty much showing why the integral of 1 over the square root of some number squared minus x squared with respect to x is equal to sine inverse of x over that number plus c, pretty much. So we'll be proving pretty much this little thing here. So the way we start this is just looking at this function here. So the function y equals arcsine of pretty much x over a, okay? What we want to do is try and work out, what dy dx is. Because if we work out dy dx, if we integrate that, then it will give us pretty much an expression, something like this, pretty much. So what we're going to do straight away is, alright, we can't differentiate this at the moment, because we don't know how to differentiate arcsine, pretty much. So what we're going to do is pretty much try and make x the subject, pretty much. So what we're going to do is sine both sides. So we have sine of y equals x over a. And then what we're going to do is move the a over there, pretty much. So x equals a sine of y. We know how to differentiate sine, but we won't be differentiating with respect to x. We'll differentiate with respect to y, pretty much. So we're going to have dx dy equals a, because it's a constant, doesn't change. If you differentiate sine, it turns into cos, so you have cos of y, pretty much. Now if we want to work out dy dx, we just flip it, pretty much, because we can treat that as a fraction. So dy dx is going to be 1 over a cos of y, pretty much. Okay. Now we don't know what cos of y is because we don't have anything else in terms of x. We have dy dx in terms of a function of y, but we don't want that. So what we're going to take a look at is Pythagorean's pretty much identity. So sine squared of an angle plus cos squared of an angle is 1. So that can be true with y as well. So that means sine squared of y plus cos squared of y is 1. So what we're going to do is try and make cos of y the subject. So we're going to move the sine squared of y to the other side. So we'll have cos squared of y is equal to 1 minus sine squared of y. To undo the square, you square root both sides, but we're just going to take the positive square root because it won't really matter in the end, pretty much. So cos of y is going to be the square root of 1 minus sine squared of y. So now we've got cos of y in terms of something else, but this is still a function of y. However, we know that sine of y is x over a, so why can't we just substitute that into there? So in other words, cos of y is equivalent to the square root of 1 minus x over a, all squared. So that turns into pretty much square root of 1 minus x squared over a squared. Okay. Now we can actually substitute this for cos y. So now we have dy dx in terms of a function of x. So what we're going to have is, alright, dy dx is equivalent to 1 over a multiplied by the square root of 1 minus x squared on a squared. Okay. What we're going to do now is, alright, well, let's try and clean this up pretty much. Let's try and move this a inside the surd. So recall a is the same as the square root of a squared. So why don't we just change it to that, pretty much. So what we're going to have is dy dx is equal to 1 over the square root of a squared multiplied by all this, pretty much. If you have two surds multiplying, you can move the stuff on the inside because they're both equivalent surds, pretty much. So it's just pretty much an index law. So what this turns into is, alright, dy dx turns into 1 over the square root of pretty much, alright, a squared minus a squared times x squared on a squared. And we can see those two cancel out. So what we get is dy dx is equal to 1 over the square root of a squared minus x squared. Okay, so that means, alright, if y equals sine inverse of x on a, that means dy dx is equivalent to 1 over the square root of a squared minus x squared. Now, if you integrate it, that's the opposite of doing differentiation. So if I integrate both sides with respect to x, I get the integral of 1 over the square root of a squared minus x squared dx is equivalent to y pretty much. Now you've got to add in a constant because when you differentiate, any constant here will turn to 0. So what you do is pretty much go sine inverse of x on a plus some constant c. And that is our little theorem that we just proved at the start. But yeah, if you have any questions about this, it's pretty much the same with cos inverse as well, and very similar to tan inverse, but I'll make separate videos on that if you want. But yeah, I hope you enjoyed this quick little video.